Alright, so moving on to the next question, we have for what values of m does the graph of y equals mx squared minus 5x minus 2 have no x-intercepts? So let's first of all write out our equation, the graph, and when we're considering any sort of parabola, we know that we can factor parabolas that have x-intercepts, or in this case, I'm going to say, I'm going to interchangeably use the word roots because the roots of a parabola are the x-intercepts. Whenever we have any roots of a parabola, normally we can deconstruct the parabola into factors of these roots, right? So x minus a is one factor and a is a root, right? So how do we find these roots in most cases? Well, in most cases, what we do is we just set the equation of the parabola equal to 0. So let's do that because we want to find out what x values we're going to have a y value of 0. And that's basically what a root is, right? So if you think of a parabola that intersects maybe these 2 points right here where the x's are, these are the roots of the equation, and normally it is where y is equal to 0. So where y is equal to 0. And in order to solve this, we could turn to the quadratic equation. So the quadratic equation is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So whenever we have a parabola set equal to 0, or a quadratic equation for that matter, we can use the quadratic equation here where a, b, and c are these coefficients of our quadratic equation respectively right here. So a is m, b is negative 5 because we have to take that minus sign into account, and c is negative 2. So plugging in for our a, b, and c, we get 5 plus or minus, well, let's take this slow, so negative minus 5 plus or minus the square root of minus 5 squared minus 4, and a in this case is m, c is minus 2, all over 2a is m. And in this situation, where we want to think about when we don't have any x-intercepts or any roots. The case of having no roots is when this quadratic equation right here can't be solved, right? So we have to see what part of this equation would make it unsolvable, or at least give us a, let's say for example, an imaginary solution. And me saying that already kind of gives it away. We know that whenever we take the square root of x, I'm going to use a different variable actually to be less confusing. Let's say we have some sort of number a, and we know that a is less than 0, then we know that the square root of a is imaginary. So in this situation, we want to find if we kind of take what we know here and apply it to the square root in the quadratic equation, we have to make sure that what's inside of the square root is less than 0, because then we get an imaginary root, or sorry, oh, my headset just died there. I see what the problem could be. Okay. Alright, so this should prevent it from dying. Okay. So we know that the square root of a has to be less than 0, and in this case we're going to say that our a is going to be what's inside of the square root. So we have to make sure that what's inside of the square root is less than 0. So we're going to rewrite, but this time in a more simplified form. So minus 5 squared is 25, and then minus 2 times minus 4 is plus 8m is less than 0. So this is our a, and it has to be less than 0. We could solve this inequality by subtracting 25 on both sides. So we get 8m is less than minus 25. And then if we divide by 8, we get m is less than minus 25 over 8. So this is the inequality, and this is the constraint that we have on m. So m has to be less than minus 25 over 8, and then we will have no x-intercepts for this quadratic equation. So that's what the answer is. So just looking at the written response here. Yep, this is exactly what I've done, and yet this is exactly the answer. So I'm going to write that is the correct solution. Good job. And the solution is correct.